So this is a quiz question. Please read through it and calculate what you find the equivalent capacitance to be. Pause the video while you do so, and then I will walk through the solution as well. I'm making the picture a bit bigger so I can have more room to write on. I'm assuming, I hope, that you have determined what you believe the correct answer to be. I'm going to show you how we need to solve for it, but I wanted to write these values down here. So the problem tells us that C1 is 50 microfarads. C2 is 30 microfarads. And then we have 36 microfarads and 12 microfarads. So equivalent capacitance. The most common answer here for this quiz is 128, which, by the way, is not correct. And that's because of where the battery is located. So again, as I've been explaining how to find and determine whether our capacitors are in series or parallel, follow a path. Always starting at one end of the battery. Here we do come to a junction, which means we can either choose to go through the 50 or we can choose to go through the 30. So the 50 and 30 are in parallel. That's totally true. Doesn't even look like the word parallel. Let me try that again. Okay, so once we have chosen to go through either C1 or C2, that gets us back to a junction where we don't have a choice. We have to keep going. And then we get to another junction where we can choose to go through C3 or C4. So C3, the 36, and the 12 are in parallel. The reason why they're not all in parallel is because as I follow the path, I must choose to go through one of these first two, but then my path takes me and requires me to choose to go through one of the right two. So the equivalent capacitance, sorry, we have a very big lag in my computer at the moment, which seems to be a common theme. The 50 and 30 in parallel we simply add the individual capacitors. So the 50 and 30 are going to be equivalent to an 80 microfarad capacitor. The 36 and the 12 will be equivalent to a 48 microfarad capacitor. Now, when we look at it in this situation, following a path, I must pass by the 80 microfarad capacitor, and then I also must pass by the 48. That means this left side is in series with the right side. So now we use the 1/over relationship for series. This ends up giving us an equivalent capacitance of 30 microfarads. So this circuit essentially could be represented by one capacitor and that one capacitor would need to have a capacitance of 30 microfarads. Now again, there's already a 30 microfarad capacitor in here to begin with, so why not just use it in the first place? Well, one reason would be the 30 microfarad capacitor potentially could not handle the battery voltage might exceed the breakdown voltage of the capacitor. So the capacitor itself, there's a maximum voltage we can apply. If we apply a larger voltage, then it ruins the capacitor. So this is a suggestion to always follow that little path. We'll be talking about resistors in the next chapter, and the path that we're following is similar in determining whether our resistors are in series or parallel. We don't have the same equations, but the reasoning is the same to determine series and parallel. This problem, we could, if we had been given the battery voltage, we could then work backwards. We would be able to find the charge on this capacitor would be the capacitance times the battery voltage. This charge, because that equivalent capacitance represents these two in series, these two would have that same charge. Knowing charge and capacitance, we could find the delta V for this one and the delta V for this one. And that's what we would take back up to the original circuit. In parallel, they have the same delta V. So the delta V I would calculate here would be the delta V for both the 50 and the 30 individually. Similarly, the delta V there would take a step back and be the delta V for the 36 and 12 individually. I wanted to show this example, though, to show you that a quick glance at your circuit does not necessarily give you a perfect idea of how the capacitors are connected. So follow the path through the circuit.